The substance that is dissolved to form a solution. Solute. A solute is the material that gets dissolved in a liquid to make a solution.
Imagine trying to fit all your clothes into a single suitcase before a trip. This problem is similar to how a solute is incorporated into a solution. Just as you carefully arrange and compress your clothes to make them fit into the suitcase, a solute is broken down and dispersed within a solvent to form a uniform solution. In this analogy, the clothes represent the solute, the suitcase is like the solvent, and the packed suitcase is the complete solution.
A mixture of evenly distributed substances. Solution. In science, a solution is a homogeneous mixture where one substance is completely dissolved in another.
Imagine trying to make sure every cookie in a batch has the same number of chocolate chips. This is similar to the concept of a mixture of evenly distributed substances because you want the chocolate chips, substances, to be spread evenly throughout the cookie dough mixture. Just as you aim for each cookie to have an equal taste and texture, scientists aim for each part of a mixture to have a uniform composition, ensuring that every sample has the same properties and characteristics.
The substance in which another substance is dissolved. Solvent. A solvent is a liquid that dissolves a solid, liquid, or gas to form a solution.
Imagine trying to fit a group of friends into a single car for a road trip. Just like the car provides the space and environment for everyone to comfortably settle in and travel together, a solvent provides the medium in which another substance, the solute, can dissolve and interact. In this analogy, the car is the solvent, creating an environment where the passengers, the solute, can distribute themselves evenly for a smooth journey, much like a solvent evenly disperses particles of the solute within it.
Forms hydrogen ions when dissolved in water. Acid. An acid is a substance that releases hydrogen ions H when it dissolves in water, making the solution more acidic.
Imagine you're trying to fit a large group of people into a small car, causing some to spill out and stand around it. This situation is similar to what happens when an acid is dissolved in water. Just as the car can't contain everyone, forcing some people outside, an acid releases hydrogen ions when it can't hold them while dissolving in water. The people spilling out of the car represent the hydrogen ions that are released, showing how acids can increase the concentration of hydrogen ions in a solution, just like the crowd increases around the car.
A compound that changes color when exposed to an acid or a base, like litmus paper. Acid-base indicator. An acid-base indicator is a substance that helps identify whether a solution is acidic or basic by changing color.
Imagine you're trying to determine whether a pot of soup is too salty or not salty enough just by tasting it. Just as your taste buds help you detect the saltiness level, an acid-base indicator like litmus paper helps detect whether a solution is acidic or basic by changing color. Much like how your taste buds signal the need for more or less salt, the litmus paper changes its hue to signal whether the solution is acidic, turning red, or basic, turning blue, acting as a sensory guide in a chemical context.
The reaction between an acid and a base, it produces a salt and water. Neutralization. Neutralization is when an acid and a base react to cancel each other out, creating water and a salt.
Imagine you've got a noisy room filled with both loud rock music and soothing classical music playing at the same time, and it's giving you a headache. Neutralization is like when you find just the right volume of each type of music so that they cancel each other out, resulting in a pleasant, balanced sound that is neither too loud nor too soft. In the same way, when an acid, the loud rock music, and a base, the soothing classical music, react together, they neutralize each other, producing a peaceful mixture of salt and water, much like achieving harmonious silence.
A mixture in which the solid particles are large enough to be seen. Suspension. In science, a suspension is a type of mixture where small solid particles are dispersed throughout a liquid but are not dissolved, allowing them to eventually settle.
Imagine you're trying to find a pair of socks in a messy drawer where everything is jumbled together. This situation is similar to a suspension, where solid particles are mixed into a liquid, but remain large enough to be seen and don't dissolve. Just as the socks stand out in the chaos of the drawer, the solid particles in a suspension are visible and separate from the liquid, highlighting the distinct components within the mixture.
A mixture with very little dissolved solute. Dilute. In science, dilute means a solution has a small amount of solute compared to the amount of solvent.
Imagine trying to make a cup of tea by dipping the tea bag into a large pot of hot water for just a brief moment. This results in a very weak brew, similar to how a dilute solution contains very little dissolved solute. In both cases, the key issue is the lack of concentration. Just as the tea lacks flavor because the tea leaves are not steeped enough, a dilute solution lacks a significant amount of solute dispersed throughout the solvent.
The scale of how basic or acidic a solution is based on hydrogen ion concentration, pH. pH measures how acidic or basic a solution is, with lower values being acidic and higher values being basic.
Imagine trying to find a perfect balance between hot and cold water in your shower to get the right temperature. Just like adjusting the water temperature involves finding the right mix of hot and cold, determining the pH of a solution involves measuring the concentration of hydrogen ions to see if it's too acidic or too basic. The hot water represents acidity, more hydrogen ions, and the cold water symbolizes basicity, fewer hydrogen ions. Achieving a comfortable shower temperature is like reaching a neutral pH level where the balance between hydrogen ions mirrors the balance of water temperature.
A mixture in which the particles never settle. Colloid. A colloid is a type of mixture where tiny particles are dispersed evenly throughout without settling to the bottom.
Imagine trying to keep a child entertained during a long car ride. No matter how often you change activities, they never seem to settle down. This is similar to a colloid, where particles are dispersed throughout a solution but never settle at the bottom, just like the child's attention keeps shifting but doesn't settle on one thing for long. In both cases, the key is constant movement. The child's shifting focus mirrors the continuous movement of particles in a colloid, preventing them from settling and maintaining a consistent mixture or state of engagement.
A solution that contains the maximum amount of dissolved solute at a given temperature. Saturated solution. A saturated solution is one where no more solute can dissolve in the liquid at that specific temperature.
Imagine trying to pack a suitcase for a long trip and you find that you've reached the point where no matter how much you squeeze and rearrange, you just can't fit in another item. This situation is similar to a saturated solution, where the solution has dissolved as much solute as it can at a given temperature, and adding more solute will result in undissolved particles, just like trying to add more clothes to your already full suitcase. In this analogy, the suitcase represents the solvent, the clothes are the solute, and the moment when no more clothes can fit equates to the solution reaching its saturation point.
A solution with more dissolved solute at a given temperature than a saturated solution. Supersaturated solution. A supersaturated solution contains more dissolved material than it normally would hold at a given temperature and is unstable.
Imagine trying to pack a suitcase for a long trip, and you've already filled it to capacity with clothes. But you keep trying to squeeze in more items by pressing down on the lid. This scenario is similar to a supersaturated solution, where the liquid holds more dissolved solute than it should at a given temperature, much like the overpacked suitcase. Just as the suitcase has been pushed beyond its usual limits to hold extra clothes, a liquid in a supersaturated state contains more solute than it would under normal circumstances, waiting for a slight disturbance, like opening the suitcase lid, to overflow or crystallize.
A solution that can dissolve more solute at a given temperature. Unsaturated solution. An unsaturated solution is a mixture that has the capacity to dissolve more of a substance.
Imagine trying to pack a suitcase for a trip, but you find that there's still room for more clothes. Just like how a suitcase with extra space can accommodate additional items, an unsaturated solution can dissolve more solute at a given temperature. In this analogy, the suitcase is the solution, the clothes are the solute, and the available space represents the capacity of the solution to dissolve more solute.